4. So subtract 4 from both sides. And we're looking at negative 9 is less than x. All right. Now, I could leave it like this, but generally I want to have the x on the left-hand side. The reason why I want to do that is because if I have it on the left-hand side, then wherever the arrow is pointing, that's where the shading is going to happen on my graph. So as just like a little strategy, it's, for me anyway, it seems to be the way to go. So if I were to do a mirror image of this, I would get x is greater than negative 9. All right. So for those who don't immediately see that, I have my little strategy that I use every year, and then I throw away the piece of paper afterwards. So piece of graph paper. So we have negative 9 is less than x. All right, so this is what you see, right? Negative 9 is less than x. You turn the paper around. What would it say if that negative 9 was written correctly?
X is greater than negative 9.
X is greater than negative 9. All right, so it's just the complete reverse of it. So you're just turning the paper around. So, but of course it looks like x is greater than p minus, but still, you know, if I go to a simpler example, like 1 is less than x, that's a better example because then you can see very clearly that that's the same as x is greater than 1. All right, so that's all you're doing is instead of reading it from left to right, read it from right to left, but change your perspective. So if your perspective is x, you're saying x is greater than negative 9, and so that's what you would write. Right? So the open circle is going to go on a negative 9, so I just have to develop a scale for this. And what I mentioned on Friday was I don't really care about you labeling the whole thing, just give me part of it. So how about this? Negative 10, negative 9, negative 8. 3 values gives a good sense of the scale. Open circle on the negative 9, and then shade to the right. All right, that idea of switching so that x is on the left, that takes the thinking out of the graphing part of it. All right, it allows you to just create the graph, just do the shading without having to put any extra thought and doing any mind bending. All right, so what do you think the first step is in number 2? Parentheses. So let's distribute that negative 2. So x squared minus 2x plus 2. Now that's going to be greater than or equal to all the other stuff. All right, next step.
Subtract x squared.
Subtract the x squared. All right, we have a whole unit later on, actually 2 units later on, where we talk about powers of x that are greater than 1, so x squared, x cubed, all that stuff. We're not there yet. So odds are, at this stage of the game, it should, if you're solving and there's an x squared in there, it should be pretty easy to do, or it should just flat out cancel. Right? In this case, it flat out cancels. So negative 2x plus 2 greater than or equal to 6. Now what? Subtract 2. So negative 2x greater than or equal to 4. Last step. Divide negative 2 on both sides. And we'd be looking at x less than or equal to negative 2. Divide both sides by a negative, you're going to reverse the direction of the sign. All right. So just need a benchmark for negative 2. So pop in your negative 2, give the values immediately surrounding it. So negative 3, negative 1. Got to do it in order. All right. So if you write negative, I've had this happen, that's why I bring it up. People would write negative 1, negative 2, negative 3, with the negative 1 being the leftmost value. That's not how a number line works. Right? It's increasing, well, the absolute values are increasing in the negative direction. Right? So the numbers themselves are getting bigger as you go out to the left, but with negative signs on them. So closed circle in this case, because it's an equality. And shade to the left. All right, so, you know, when you have to do something like this, there's a fair amount of steps involved, but they're not overly challenging steps. Now, as far as how you represent your final answer, it said express your answers in set notation. So just remember, the only adjustment on that is to put a vertical line, an X, and then those squiggly brackets. Same thing in the case of the second one. Vertical line, an X. Well, actually, this one I'm going to write over because it's a little messy. So we would write squiggly brackets, X, given that X is less than or equal to -2. All right, so the reason that's important is because it flat out asks us to do it, but also we're going to have to learn the difference between set notation and interval notation. All right, and so if you're not careful about stuff like that, you could end up with a little bit of trouble. All right, and so again, all you're doing is taking your answer and building this other stuff around it. It's the same every time, except maybe the variable might be different. All right, interval notation, that's the subject of today's lesson. It's not overly challenging. It's just building off of what we came up with over here in our do now problem, except we're using a different way of representing our final answer. So interval notation, the interval is a set of all numbers between two endpoints. All right. In interval notation, the brackets are used to include the endpoints. The parentheses are used to exclude. All right. The exception being infinity. Well, it's really not an exception. It's more so that infinity is a number that's in motion. You can't actually get to infinity. So how can you include something that you can't actually get to? All right. So that would be these values that I'm highlighting in the table here. So the example below, and I'll take you through a couple of them, but the example below here is saying, you know, you were working off the number line, so basically you did all the stuff that we did in the do now problems, but now I'm representing this in interval notation. The lower end point is 1. The upper end point, quote unquote, would be infinity. You could never actually get to infinity, so we put parentheses on it. You can actually get to the 1, so I put a bracket on it. All right. If it were an open circle at the 1, then I put parentheses on that also. All right. So it's a question of whether or not you could actually get there. If you can't get there, it's parentheses. If you can get there, then it's bracket. All right. So let me take you through some numerical cases on the next page, and then I'll set you free.